right, this is for those in class that have needed help with logarithmic expressions. So this is just review material. If you know your logs, then you don't have to watch this video. So I'm going to be talking about working with exponents and logarithms. So what is an exponent? The exponent of a number says how many times to use the number in a multiplication. So for instance, 2 is the base and 3 is the exponents. Logs are they just go the other way around. It asks what exponent produced this. So 2 to the what equals 8 is what a log is asking for. We just write it like log base 2 equals 8. Log base 2 of 8 equals 3. So what the log is doing is finding out what that exponent is. So they're really just opposites of each other. So log a x equals n means that a to the n equals x. Number 2, log x means log base 10 of x. All log base a rules apply for log. When a logarithm is written without a base, it means common logarithm. ln of x means the log base e of x, where e is about 2.718. All log base a rules apply for our natural logs, and when a log is written ln, it means natural logarithm. For each of the above and the following slides, assume that x, y, a, and b are all positive, and that a and b do not equal 1. So, basic rules. In math terms, multiplication inside the log can be turned into addition outside the log. Division inside the log can be turned into subtraction outside the log. And an exponent on everything inside a log can be moved out front as a multiplier and vice versa. So where did these rules even come from? Since logarithms are nothing more than exponents, these rules on the previous slide and to the left come from the rules of exponents seen to the right. Let a be greater than 0 and not equal to 1, and let n and m be real numbers. So as you see, when you multiply logs, you add them. Those rules come from the exponents because logs really are just the opposite of exponents. When you divide, you subtract. When you raise it to a power, you're going to end up raising that power, multiplying the powers. You can evaluate a non-standard base log by converting it to the fraction of the form standard base log of an argument divided by same standard base log of the non-standard base. So this is what I'm talking about. So log base b of x will equal log base d of x divided by log base d of b. You can change b to any d by doing this formula. Inverse properties. So log base a of a to the x equals x, and a to the log base a of x equals x. They are inverses of each other. So be careful. When I was making the rules earlier, log x plus y does not equal log x plus y. Remember, it's log of the multiplication can be written as an addition, and log of the division can be written as subtraction. A lot of people make these mistakes and say addition is addition, subtraction is subtraction, but these do not exist. These cannot be simplified in this manner. So, the important thing is that a logarithmic function can be undone by the exponential function and vice versa. So, example, what is x in log base 3 of x equals 5? So, we can use our exponent with a base of 3 to undo the log. So, we can rewrite it as 3 to the log base 3 of x equals 3 to the 5. So, what we did was raise both of these, put 3 right here, and put these in the exponents. This is an inverse property. Therefore, we know that this cancels out to equal x, and that equals 3 to the 5, so x equals 243. So the natural logarithm and natural exponent functions. Here are the graph. You can kind of see their relationship with each other. Natural log goes in this function and goes e comma 1, and it passes through the point 1, 0 and e1. This one, e to the x, goes in the other way, and it passes through 1e or 0, 1. So that's why I say they're kind of opposites of each other. So solve 2 log base 8 of x equals log base 8 of 16. So what we can do is we can take this 2 and put it on the x squared, because we could do this reverse way of one of the rules that I gave you. And that way the log base 8 and log base 8 kind of remove the logs. They're the same base, so they don't matter anymore. So x squared equals 16. So x can either equal negative 4 or positive 4. But you can't have a log of a negative number, so it must be the positive 4. If you don't believe me, check it in the calculator. So solve e to the negative w equals e to the 2w plus 6. So apply ln to both sides. And ln to the e to the w is going to equal w. And over here, ln to the e to the tw plus 6 is going to equal tw plus 6. Therefore, we really just have this negative w equals tw plus 6, which simplifies to negative 3w equals 6, and w equals 6 divided by negative 3, or is negative 2. And below is how you can check that. And that's it.